Now, much like the notes on a guitar or any real instrument, you can actually combine separate functions into a giant function. For example, if I look at the guitar here, I can look at each note as part of the input and the sound that it makes as the output, and I could create a series of functions. For example, I can take the function of the A string here and a similar function at the G string here. And while they exist separately, I can combine them into one function that work harmoniously. See? And so combining functions kind of works the same way. Let's take a look at how we could do this traditionally. So in order to do operations with functions or to combine functions to make one giant function, we can do any of the following four operations. We can have a sum of the functions of f at x and g at x, and that would look something like this. Now we're going to, of course, break these down into more specific examples. You can have the difference of f and g, which again looks like the f at x minus the g at x, and this can be in the form of products as well. We could have the product of f and g, where f at x times g at x gives us one mega function. And of course the quotient, which is another word for division of f and g, where f at x is divided by g at x. And in this case, of course, g at x cannot be 0, because then your entire expression would be undefined. So let's say we're asked to consider the following functions, where f at x is equal to x cubed minus 2x squared plus 6, and g at x, a separate function, is equal to x cubed minus 2x plus 6 as well. So in that case, what would f at x plus g at x be? Well, what we're going to do is we're going to put in giant brackets for f at x. We're going to substitute this into the function, so it'll be x cubed minus 2x squared plus 6. And then we're going to add g at x, which would be this function over here. And we would substitute x cubed minus 2x. And then this would be plus 6 as well. So we can combine the like terms, x cubed and x cubed combined to make 2x cubed minus 2x squared. There is no other x squared there, so we're just going to rewrite that down there since it just carries over. And that's the same with the minus 2x over here as well. So we're just going to write minus 2x. And then, of course, the two sixes, the plus 6 and plus 6 here, do combine to make a total of plus 12. And so we can rewrite this as f plus g at x is equal to, and then this would be the function over here, 2x cubed minus 2x squared minus 2x plus 12. Let's do f at x minus g at x. So we're going to have the same approach or same formulas that we're subbing in. Now, instead of having a plus between the two functions, we have the minus, because that's what the question is dictating here. The x cubes will cancel out. Minus 2x gets brought down because there's nothing else to cancel it out here. The 6's are removed. And then, of course, the minus 2x over here gets brought down. So then we can write it as f minus g, both at x, is equal to, and this is the final function over here. Now let's say as a follow-up question, we're asked to find f at x plus g at x at 5. So that's when the x value equals 5. How would we do this? Well, we could skip right to the equation that we know for f at x plus g at x, and we can simply just substitute the 5 in for all the x values. So that would look like this. We'd have 2, 5 cubed minus 2, 5 squared minus 2 times 5 plus 12. That would give us 2 at 125 minus 2 at 25 minus 10 plus 12. And so when we add this all up in the calculator, we get the following. And that's a value of 202. Multimedia Production Company produces DVDs which cost $3 per unit. So when we're talking about unit, we're talking about per CD. So that can be thought of as X. The fixed costs, including the graphics, are $10,000, irrespective of the number of DVDs produced. Each DVD retails for $15. Write the total cost as a function of the number of units produced. So we'll start off with this one here. So for A, if we think about C at X is the cost, we know that it costs $3 per unit. And then $10,000 regardless of how many CDs are sold. So let me just rewrite this here. I'm going to write it with all the appropriate units. So we're going to go $3, so 3x, and then plus $10,000 that appears to be a constant. Now in terms of cost, that is pretty much it, because this $15 pertains to retails. Okay, so that's how much it's sold for, not how much it costs in terms of the company. Now, for B, the revenue, R at X. Well, it seems that the only way that money can be made is by selling the CDs, and there's no guaranteed revenue other than the selling of the CDs, which would be $15 per CD that's sold. So because there's no other capital, then our revenue function is going to be R at X is equal to 15x. Now the profit. Profit is going to always be revenue subtracted from the cost. Right? So revenue is how much money can be made, and then cost is how much it costs to make the product. And so when we think about profit at X as a function of X, then that would be 15.00x minus 3.00x plus $10,000. And then that would simplify to, these would simplify over here as like terms. That would simplify to $12.00 per CD X minus $10,000. Now, what essentially are we doing here with this part of the function? Well, if I were to really assign these, that would be R at X minus, it should be C at X. And basically what I have is that the profit is a difference function between R at X and C at X. And so this is the final equation here.